Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is a Z390 gaming board with 1151 socket. Oh, it's optical audio output, and we have PS2. So pretty decent gaming board. Oh, nothing special, as you can see by the coils on the core. There's not a lot of them, but they are pretty significant, meaning pretty big, pretty beefy. We have electrolytic caps, so we're gonna have to put some aluminum foil on them. And we have a single 8-pin connector for the core. So decent. I mean, 1151 sockets, they don't support like super high-end CPUs nowadays. So it's nothing special, but it's pretty decent board. Now we received it from Tim, and Tim had some questions regarding, let me see here. I'd like to see how you set up that BGA station. I see that pop can and pleasantly surprised. Well, it's been a while since I used a soda can nozzle. Now, what I use is IR, and the difference, because a few people, especially those who purchase my Rework Pro software, they ask regarding, kind of tips moving on from HUD stations to the IR stations. And there is a significant difference. With IR, you set the temperatures much lower. I think the maximum temperature you can set on IR is 250 degrees, something like that. So obviously on hot air, you wouldn't be able to do it at 250. I mean, probably depending on what kind of hot air station you're using. But it's the sockets start melting at 260. But 260, when you set it on the soldering iron, right? You touch it with 260, and you can damage it, sure, because it's metal and plastic. But the plastic is not melting at 260, and that's usually the highest temperature you can use on those boards to not risk the melting. However, it all depends on the profile, and profile is very difficult to do on the hot air stations, because the temperature that is being measured is the temperature of the heater. The heater is roughly somewhere around here, well, maybe around here, right? And there's a thermocouple inside on the heater, on that little spiral, and that temperature is kept at the whatever level you set it, right? So obviously that heater is being cooled down by the air rushing through the hot air gun. So the temperature you have is very different, or the profile is very different. How do you regulate temperature on hot air? You move it closer or farther. That regulates the temperature. So you can set it to say 450 degrees on the hot air. And if you need 300 degrees, then you hold it far away. If you need 400 degrees, you put it closer, and so on, right? So the distance between the nozzle and the object you're heating determines what the temperature is actually going to be. On infrared, there's no such limitation. Infrared, being a radiation, regardless of the distance, it will roughly be the same. However, the heater itself is also very hot. So you can see that if you normally the heater is 3 centimeters away from the socket, and you can see that if you just even stop the heater and you just lower the nozzle, lower the heater, you see the temperature skyrocketing, right? Because that heater is also very hot. So that distance is not that important, but you have to keep it at a constant distance from the object. Now, as far as the temperatures, you can see everything on the Rework Pro at the bottom. The bottom heater heats up the board to roughly 210 degrees. I preheated for roughly 15 to 25 minutes, not on 210. First I go to maybe 120, 140, Then I raise up and up, just so the board slowly heats up. You don't want to heat it up too quickly, or it's going to start bulging and, well, maybe not bulging, but it's going to start deforming. You want to heat it up relatively evenly. Now, my heater only heats like this area over here, like maybe roughly this much, right? So not the entire board. It's better if you have Elstein heaters. For Elstein heaters, they cover pretty much the entire board. So it heats up a lot more evenly. That would be better, but I don't, well, I do have heaters, I just have to build it up. I haven't really had time to, or more like motivation to actually do it. This heater works pretty well. Once it's up to roughly 205 degrees, 205 degrees, I start the profile before the bottom of the board reaches the very target temperature, so I can take advantage of the bottom heater as well. That is the problem of my setup, because the bottom thermocouple sits somewhere around here. So once the top heater starts heating, the bottom heater just kind of reduces the power because the temperature is growing. But that's fine. It works pretty well. But the trick here is that the temperature of the top heater is lower than the temperature of the bottom heater by roughly 5 degrees. Now, 1151 sockets are relatively easy because they're small. There's a little over 8,000 pins that you have to solder on. On AM5, you have close to 2,000 pins. Well, 1817 there are, right? 1,800 pins on AM5. But you at least don't have to worry about those caps inside. So that's an advantage as well. Looks like we have a couple pins completely broken off. This one is probably just bent, yeah. So this one could be bent into position. There you go, and it's fixed. We have a nice outline. Yeah, it looks okay. I mean, not the best, but it looks perfectly fine. Electrolytic caps, yeah, let's cover them. I mean, the temperature of 205 degrees shouldn't actually damage the cup. But if the cup explodes, that means the cup was faulty. It already started leaking, most likely. But it's kind of a rule of thumb. It also probably depends on the cup and the age of the cup as well. Surprisingly, the ones that are, well, maybe not surprisingly, but counterintuitively, the cups that are dry, they're not gonna explode because there's not enough electrolyte inside to build up pressure to actually explode the cup. Now, when they explode, it's not like the top explodes. They just detach from that plastic at the bottom and just ooze the electrolyte from it. So it's not very dangerous, although I definitely recommend wearing some eyewear or the whole face mask when you suspect that the electrolytic cup might explode, just to be safe. Alrighty, the bracket is removed. The board came in disassembled. The bracket, the CPU bracket, you don't have to worry about that because the primary difference between the assembled and disassembled is in the mass of the board. If you have all those heat sinks on PCH, V-Core, sometimes there's a big plate in the back and stuff like that, that impacts shipping dramatically. That's why this is $50, this service. Doesn't matter what socket. If you're sending assembled board, that's $75, but those prices will go up probably relatively soon. So if you're planning on getting a cheap socket replacement service, act fast. Limited time offer. All right, let's speed up the footage and let's get it done.
Over the edge, feel like I'm floating through the air. The pain I felt is paid for, all is said and done. Oh, I am restricted, fixed upon the web. I need to kick the habit that my mind is breathing in. Break out, I've got to see. Burning the bridge that keeps us. I'm here and I'm fearless. Exaggerated, that's what you assume. The story's over now, I must conclude. I am conflicted, watching where I step still, hanging in the balance. Not the life I want to live, I want to take it all. Standing tall, fear I weighed the person you are. Oh, break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless.
And there you go, we're done. So socket dropped at 185 to 195. I don't know if you guys caught that. I didn't catch it during the procedure, actually. I had to review the footage. Alignment seems okay. Seems actually pretty perfect. There are some specks of flux left here and there. I didn't want to overdo it in the ultrasonic cleaner. This is no clean flux. Typically, if the board is a candidate for RMA, I will leave it as clean as I can possibly do. In this case, as long as there's no flux like visible in the socket or stuff like that, then it's all good. Yeah, there's a little bit over here. We could clean that with the Q-tip, but that's fine. Alrighty, now 1151s and 1200s. The only problem with these is that, and all of this kind, is that you have those cups inside. So both cleaning is a little pain, and obviously removal and replacement. This one doesn't have a lot of them, but some of them have plenty of those cups. One wrong move, and those cups, especially at the temperature of 210, they're just going to clump together, and it's a pain. You just have to remove them all and clean the board and solder them on one by one. It's an extra, I don't know, maybe hour and a half to fix that. So definitely steady hand is relatively important. Or, well, you know, again, if you move them, you can just replace them. That's not a big deal. It's just a matter of time. But this is it. Yeah, it looks good. Looking at it from different perspective to see how it reflects light, that tells you whether there's any flux left anywhere, right? As long as you don't see any discolorations, any blobs or anything, it's all good. Now I used my latest batch of flux for this. It works a little better, I think. it does, you see bubbling, right? But for BGA work, as soon as you put it on, it's a little bubbly, but that's alcohol evaporating and glycerin turning into smoke, right? So that's not a smoke from the actual resin. It's the same thing they use in vapes, right? So once that boils off, you're left with the nice even layer of just resin, right? And that's when you put the socket or whatever you're soldering, right? You could, when it's hot, you could use like a Q-tip or something to just spread it around, but you're risking that the Q-tip is going to leave some fibers and they're going to interfere with the process. You might cause bridges and stuff. So I recommend not doing that, but just nice little miniature layer, the minimum amount you can. Just spread it around, wait for everything to bubble off, right? For the nice little, nice uniform layer to be created, then put the socket on and it should clean pretty well. You can still burn it if you hold it for too long, too high temperatures. It will burn, and it's a pain to remove once it burns. But with ultrasonic cleaner, it's not that bad. If it's really giving you problems and you really have to clean it really well, then just submerge it in alcohol and just keep it there for, I don't know, 20 minutes, half an hour, what have you. And it should let loose with just a soft brush, right? It should be really easy to remove. But hey, to each their own. I know Alex has a really good flax. I've seen what was it today? I've seen the video of Northwest Repair testing that flax, and yeah, it definitely looks like it's superior to my flax. But there's advantages and disadvantages of everything. And as you can see, I only use my flax. I don't look for any other flax. It works great. It smells great. It gets the job done. Alrighty. Thank you guys very much for watching. Thank you, Tim, for your business. Hope you're going to be happy with this. It looks like a perfect success. The board is flimsy. Oh, the board is very flimsy. So, yeah, we'll see. These older boards, they can get flimsy like this. So, yeah, be careful with this. Well, let's hope it works. If it doesn't, we may have an issue with some traces breaking. Right? I don't see any physical damage. It should be good, but well, I guess you'll let me know. In either case, thank you very much for your business. Thank you guys very much for watching, and I shall see you in the next one.